Okay, the first question, physical quantity which has the same dimensions as work is. If you remember, the definition for the energy is the ability to do work is the energy. So ability means like, both energy and work should have the same dimensions. They have the same units as well. The energy and the work should have the same dimensions. Force, power, pressure and momentum, those are other physical quantities. Work and energy are the similar physical quantities, so they have the same dimensions. So the answer for the first question should be the fourth one. Okay, second question. The sound wave with frequency F and amplitude A moves through a medium with density rho. Correct equation that represents the energy in a unit volume could be, and they say that K is dimensionless. Okay, so energy in a unit volume. So that is capital E, energy in a unit volume, meaning you have to divide the amount of energy by the volume that energy is contained. So this should be energy divided by volume. So the dimensions of energy is same as dimensions of work. So mLT minus 2, that is for the force times distance is the work, which has the same dimensions as energy. Then divided by L cube. Then if you simplify this, you get ml minus 1 t minus 2. So this is the dimensions of energy in a unit volume. So we have three equations, A, B and C. We have to choose which one has the same, which equation has the same dimensions at the both sides of the equal sign. So the dimension should be this one, right? ml minus t1 minus 2. So let's check it now. First one, rho A F squared. Rho is the density, so dimensions ml minus 3. This amplitude is a length. If you remember, for waves, this length from the midpoint to the peak of a wave is the amplitude, so that is a length. So L. Then frequency, dimensions of frequency is t minus 1 and it gets it squared. So this should be ml minus 2, t minus 2. So if you compare these two don't have the same dimensions. The dimensions are different. So we cannot get A as an option. Then let's calculate the B expression. That is rho A squared F squared. Rho is ml minus 3. A squared is L squared. F squared is t minus 2. T minus 1 to the power 2, so t minus 2. So you get ml minus 1 t minus 2. So these two have the same dimensions. So B is a correct equation. Then if you think about the expression in option C, this has only multiplied by a dimensionless constant. So these are the same equation, but this is only multiplied by a dimensionless constant. So this doesn't change. Dimensions of this doesn't change just because it is multiplied by dimensionless constant. So the dimensions of this one also should be ml minus 1, t minus 2. So that also has the same dimensions as here. So this is the dimensions of energy contained in the unit volume, ml minus. Then these two also have the same dimensions. So B and C should be the correct options. So the correct answer should be the fifth one for the second question. Okay, the third question. Image shows main scale and a Vernier scale of a measuring instrument. Reading shown by the image in centimeter. So they ask, so this is the part of the Vernier scale in the measuring instrument. So what they ask is what should be the reading shown here. So get the reading. There's a part of the reading that should be measured by the main scale. Then the other part should be measured by the Vernier scale. Then that is a main scale reading plus Vernier scale reading. So for the main scale reading, first thing you have to do is to figure out the zero mark of the Vernier scale. Okay. So for that we cannot, depending on the question, we cannot say that zero mark is here or here. But for sure we can say that fifth mark of the Vernier scale should be this at this division. Then 1, 2, 3, 4, 5. So the zero mark should be this point, not this point. In the question, zero mark is here, but it is not the zero mark. Zero mark is this. Okay, now we know. So that is the first step to figure out the zero mark. So this is important, right? The zero mark is not the edge of the Vernier scale. Vernier scale, when you take the measuring instrument, many students take the zero mark as the edge. It is not the edge. You have to figure that out by looking at the image carefully. Which one is the zero mark? So up to zero mark, you can take measurements from the main scale. So if you think about that, this should be 8 centimeter. Then at here it is 8.5 centimeters. Then you can measure up to here using the main scale. So that should be 8.6 centimeter. This point should be 8.6 centimeter. The remaining length should be figured out by the Vernier scale. So for that we need to find the coincident division. If you carefully look at the image, the coinciding mark of the Vernier scale is 1, 2, 3, 4. This part 1, 2, 3, 4. This is the coinciding mark. That is the fourth mark, right? Fourth mark. So to get the Vernier scale reading, coinciding part is 4. Then just multiply it by the least count. Least count. Least count of this Vernier caliper should be 0.1 millimeters. But here we have taken, when you add these, you have to make sure that both parts should be in the same unit. If this is centimeter, this also should be in centimeter. But since this is in millimeter, I can convert this into centimeters by dividing this part by 10. So the least count I can convert into 0.01 centimeter. Then if you add this 8.6 centimeter plus 0.04 centimeter, then you get 8.64 centimeters. So this is the reading shown by the this part of the Vernier scale shown by the image. Okay, the fourth question. The equation that can be used to measure the radius of curvature of a spherical surface is. Symbols have usual meaning. So they are asking just for the equation. So which equation which is the correct equation? That's what they ask. I'll just remind you, I'm not going to prove the equation here. So here, let's say this is a curved surface. So if we need to measure the radius of the curvature, this is the radius of the curvature. This is a curved surface. You can think that as a part of a sphere. Then this radius becomes, this length becomes the radius of that curvature. Then this is capital R. Simple h is this height. This height. Then simple A is this length. So this is a cross section of that the scenario, cross section of the curvature, right? So those are just the measurements. I'm not going to prove how to get the equation. You are supposed to remember the equation to find the curvature, radius of curvature of a curved surface. So the equation for that, you have to remember that R equals a squared over 6h plus h over 2. So if you remember this, simple h should be measured using a spherometer. Okay, using a spherometer. Right. So the answer for that should be the third one. A squared over 6h plus h over 2 is equal to capital R. Okay, next question, fifth question. Using a Vernier caliper with least count 0.1 millimeter, length of 2 centimeter is measured. Then they are asking for the percentage error of this measurement. So if you remember the equation for percentage error, for percentage error it's equal to least count divided by measurement times 100%. Least count divided by measurement times 100%. So the least count of this apparatus is 0.1 millimeters. And the measurement they are taking is 2 centimeters. But 2 centimeters should be in the same units as millimeters. So it should be 20 millimeters. Then multiply by 100%. 20 and for 100 it is 5 20s. Then just multiply it here. Millimeter cancels off. Then this is 0.5%. 0.55%. That's the percentage error for that measurement taken by that specific apparatus. I'll just remind you a fact that if this percentage is more than 1%, you cannot use that apparatus to take that measurement. That percentage error should be less than 1%. That's just to remind you of fact there. Okay, this is how you can measure, how you can calculate the percentage error. Sixth question. The ball is released from top of a building. Takes 8 seconds to hit the ground. Okay, a ball is released, meaning initial velocity 0, and it takes 8 seconds to hit the ground. Gravitational acceleration 10 meters per square second downwards. So then they are asking the velocity that it hits the ground and the distance it moves down. So to find the velocity that it hits the ground, I just apply this equation. Initial velocity 0, acceleration 10 times the time taken is 8 seconds. So the velocity should be 80 meters per second. This is the velocity that it hits the ground. Then I need to find the height. I'll just use this equation. This is a bit easy to use since you know the initial and final velocities and the time it took. This equation is a bit easy. Initial velocity 0, final velocity 80 divided by 2 times time is taken is 8 seconds. So 4 times 80, that should be 320 meters. So the velocity is 8 meters per second, then the height it moved is 320 meters. So the answer should be first answer 80 meters per second and 320 meters. Answer is first answer. Okay, then 7th question. Water level of a deep well is below 20 meters from the ground. So this is the ground. Water level of the well, let's say at somewhere here. That is at a depth 20 meters. Then a stone is dropped into the well. Dropped means initial velocity of this stone should be 0. It is just dropped, right? Then there's time that the sound of the stone hitting the water is heard after it is dropped is. So they're asking for the time. Then when the stone hits the water level, it makes a sound. Then that sound takes some time to reach the ground level again. So what they ask is the time taken from the moment that the stone is dropped. So the time here is 0. First we need to find, let's say the time for the stone to reach the water level is T1. Then it makes a sound. Then another time, it takes some time for that sound to reach the ground again. Let's say that time is T2. Okay, first let's find T1. I can simply apply this equation downwards. So the S is 20, initial velocity 0, half, acceleration 10, then T1 is squared. 20 equals 5t squared. You cancel this 5t squared, then t squared is equal to 4, then t is equal to 2. This is actually T1. This is the time for the stone to go from here to here, move from here to here. Then it makes a sound. Then the sound wave has to reach the ground level. Then let's calculate that time period. Normally, sound waves travel at a constant speed, which you will learn more in waves and oscillation unit. Those sound waves have a constant speed. So I can simply apply S equals ut for this case in order to find T2. So the distance it moves upwards is 20 meters. The speed of sound is given as 330 meters per second. Then the time is T2. Then T2 is equal to 2 divided by 33 seconds. 2 divided by 33 seconds. So 2, 0, then 20 doesn't have 33, so 0. 200, 33 has 6 33s. So it should be 0.06 seconds for the sound to move from here to the ground level. So the total time, what they are asking is T1 plus T2. That is 2 plus 0.06. That is 2.06 seconds. So this is the total time that for this phenomena to happen. So that is 2.06. So the answer for the 7th question should be the 3rd one. Question number 8. An object that can project with the speed u gains a horizontal range root 3 u square over 2g. Angle of initial velocity of projectile that makes with horizontal. This is a projectile motion question. So the question says initial velocity of the projectile is u. Let's say the angle, this is what they ask. Let's say the angle is theta. But for this one, the horizontal range is given as root 3 u squared over 2g. This is the horizontal range of the motion. So using this data, you have to calculate this angle theta. This is the angle of the initial velocity that makes with the horizontal. Okay. So simply as usual, you just have to apply linear motion equations. I'll name these points as OA. So from O to A, I'm applying equations, this equation upwards. So this is the normal procedure that you have to do in order to find the horizontal range of a projectile motion. So if you apply it from O to A, vertically upwards, it goes up as the object moves from O to A. Vertical component moves up and again comes down. So the displacement should be 0. Vertical displacement is 0 because that component is right at the beginning again. So the 0. Then vertically, what is the vertical component of the initial velocity? That should be u sine theta, right? This component u sine theta, this component should be u cos theta. The vertical, this is u sine theta times, let's say the time taken is simple t plus half. Acceleration, equation is applied upwards but the acceleration downwards, so it is minus g t squared. T, this one cancels off. Then g divided by 2, t equals u sine theta. Then the time is 2u sine theta divided by g. So this is the time for this projectile motion, total time. Then I just apply equations horizontally. S equals u. Horizontally, the total displacement is root 3 u squared over 2g. U is u cos theta. U cos theta times the time. That time is 2u sine theta divided by g. Okay. And this is u squared. This also, if you simplify this also u squared. That gets cancelled off. G cancelled off. I can take 2 sine theta cos theta is equal to root 3 divided by 2. 2 sine theta cos theta equals root 3 divided by 2. So if you remember, the maths students already know, but bio students also should supposed to know this equation. If 2 sine theta cos theta is sine 2 theta, right? Early days, you're supposed to remember those equations. 2 sine theta cos theta is actually sine 2 theta. So instead of that, I'm putting sine 2 theta there. Root 3 over 2 is what's the value in terms of sine? Root 3 over 2 is sine 60. So sine 60 is equal to sine 2 theta. Then we can say 2 theta is equal to 60 degrees. Then theta should be 30 degrees. So okay, now we found a value for theta, that is 30 degrees. Yeah, 30 degrees should, it is this angle is 30 degrees. But the thing is, if you kind of remember, do you remember for theta and 90 minus theta, in both situations, we will have the same horizontal range. We will have the same horizontal range. The answer we got here is 30 degrees for theta. Meaning that for this horizontal range to happen, both of these angles are true. So if theta is 30, this works for 90 minus 30 as well. So this works for 30 degrees and 60 degrees. 90 minus 30 means 60 degrees. 30 and 60 degrees. So the answer for this should be the fourth one. Ninth question. A ball is projected along a smooth inclined plane of 45 degrees at 10 meters per second. Okay, this is an inclined plane and it is smooth. Inclination is 45 degrees. It is projected upwards at 10 meters per second. So what they ask is time required for it to come back from the beginning. Beginning means here, right? So it goes up and comes down. What they ask is the time for that whole motion. So if it comes back, as it comes back, the displacement of that should be 0 because it is again at the initial position. So you just have to apply this equation. Vertically upwards, vertically upwards, but along the plane. So this is 45 degrees. So if it is again at the initial position, displacement should be 0. So for that to happen, we need to find the time. Initial velocity, that is 10. Time is simple t, let's say, plus half. Then this is the simple a. That's the acceleration. If you remember, this object is since this is a smooth surface, this is only submitted to the influence of gravity, mg, right? So if it is mg, the force as it moves, the force acting on that is mg. Meaning this has an acceleration downwards, simple g, but due to this plane, it cannot have that acceleration. So we have to consider a component of this acceleration along the plane. So if we think about that, this angle is 45 degrees. I can say g cos 45 or sin 45, both are same values. So if you remember the acceleration for something like this is always downwards and g sin theta. Here the theta is 45 degrees. So if I substitute g means 10, sin 45, t squared. T cancels off. Then this is 5 sin 45. 5 sin 45 is equal to 10. 5, this is 2. T times 1 over root 2 equals 2. That t equals 2 root 2. So this is the total time that is required for this whole motion. 2 root 2 seconds. So the answer for that should be the fifth one, for the ninth question. Okay, next question. Two objects A and B moving towards each other at U and V are at a gap S. So at a considered instant, we have two objects A and B. Those have velocities U and V, and at that particular moment, the gap between them is simple S. So when they move to, then at some point in between these 2 points, these two objects would meet. So what they ask is the time required for this meeting to happen. Okay. There are like two ways to do this. We can use a relative motion, or we can simply apply linear motion equations. Since it's a constant velocity equation, we only need s equals ut. Relative motion also is easy, right? So if we need to apply, I'll just solve this in relative motion. If you need to apply relative motion, I'm going to solve this question in a frame of one of the object. Let's say I'm applying this in A's frame of A. So if it's frame of A, all the things should be relative to A. If you are going to solve this in A's frame, everything in this should be relative to A. So first I need to find relative velocity of B, velocity of B relative to A. So if they are moving to opposite direction, we know that the relative velocity between them should be the sum of the velocities. So the relative velocity should be u plus v. Then let's say the time it takes for these two to meet is simple t from this instant. So if that is the case, so what this is relative to A means, if A is stopped, the distance B has to move is from here to here. Then if I apply here S equals ut, so this displacement also is relative to A. As relative to A means as seen by A. As seen by A means if stop, you can think that as if A is stopped, B has to move from here to here, meaning S distance in order to meet. So I am applying this equation in A's frame. So the distance that B has to move in A's frame is S. Then this also should be relative to A. That velocity is u plus v times t. So the time is S divided by u plus v. So once you get used to this one, the relative motion, using relative motion, when two or more objects are moving, using relative motion is the easiest way to solve this kind of problem. It looks complicated, but once you get used to that, it will be much easier rather than using linear motion equations, just linear motion equations. Right. So the answer for that should be fourth one for the 10th question. Okay, our next question, 11th question. A horizontal force of 2.5 Newton is applied on an object with mass 2 kilogram. So the object has a mass 2 kilogram that is on the ground. The horizontal force applied is 2.5 Newton. Then they say a limiting friction coefficient. Let's say mu L, that is 0.5. Then the kinetic friction coefficient is 0.4. Then they ask in this case, what should be the friction acting on the object? So the friction force is acting opposite to this force, 2.5 Newton. So when you get a question like this, first thing is you need to find the maximum possible friction, that can be applied by the ground on the object. So for that, we need to apply this equation. So this is a F max, right? Also called F limiting friction. So for that, you have to substitute here limiting friction coefficient. So the limiting friction coefficient is 0.5. Then the normal reaction force, capital R, is normal reaction force. So we know that this is a normal situation. So if the weight of is 20 Newton, the normal reaction also should be 20 Newton in a normal situation, right? So the R is 20. Then 0.5 times 10 is 10 Newton. That is the maximum frequency that the ground can apply on the object. Does not mean that this is the friction acting. This is the maximum friction that can be applied by the ground on the object, right? It's a maximum. This can be applied, but it does not mean that is the friction that is applied. Okay. So the applied force is only 2.5 Newton. We don't need this much of a friction in order to keep this object in equilibrium. We only need a friction of 2.5 Newton. Okay, now it is just 2.5 Newton. This is the friction we need. We don't need 10 Newton. This is just to check whether this applied force goes goes beyond 10 Newton. Applied force is less than less than 10 Newton. So the object cannot move in this case, meaning this object remains in equilibrium. For this to be in equilibrium, the friction required is only 2.5 Newton. So the answer for that should be the first one for the 11th question. The question: a rocket weighing 5,000 kilogram. 5,000 kilogram. Meaning this is weight of this is 50,000 Newton. Releases air at 100 kilograms per second. So the rate of mass or the mass of air released is 100 kilograms per second from this nozzle, right? Then that air moves downwards at 1,500 meters per second relative to Earth. So under these circumstances, what they ask is acceleration of the rocket. So you know, when air is pushed down through the nozzle of the rocket, that is how it gains the force it required to move upwards. So let's say that force is capital F. So we have an equation to get this force. This force is actually divided by T. Mass divided by T, V minus U. M over T, that is the mass flow rate, that is 100 kilograms per second. Initially, the rocket fuel or the air inside the rocket is at 0 velocity. Then it gains this velocity as it exits from the nozzle. That is 1,500. So then if you simplify this becomes 1.532 10 to the power 5 Newton. So this is the force generated due to release of air. Okay. Then we have found, we have gained all the forces required, external forces acting on the rocket. Then simply apply F equals ma upwards. So F is, this is 1.5 10 to the power 5. If I write this in scientific method, this becomes, I need 10 to the power 5. So I can write this as 0.5 times 10 to the power 5 equals mass of the rocket is 5,000. Acceleration. Then I'm dividing the whole thing by 10 to the power 5. And you get a 0.1 here. So 0.5 here. 10 to the power 3, 0.5, 0.05. So this is a 1.5 minus 0.5, 1 equals 0.05 acceleration. 0.05 means 1 over 20. So 20. So the acceleration gained by the rocket is 20 meters per square second in this case. So the answer for that should be the second one for the 12th question. Question 13th question. When a fluid hits the wall at V to it and it stops. So let's say the speed of the fluid V, then it exerts, it is incident on this wall. This causes a pressure to be applied on the force, to be applied on the wall. Okay, before that, you need to know this. Pressure is force divided by the area that it applies. So force divided by area, right? So if the velocity is V and the phi, once it is incident on the wall, then they say the speed of liquid becomes 0. So in this case, pressure applied is P. Then they say, if the fluid jumps off the wall at V, so that's the second case. It hits the wall at V and it doesn't stop. It doesn't, the velocity of the fluid after hitting the wall does not become 0. It becomes V and it bounces off. So for this one, velocity V, then it becomes 0, meaning it would pour along the wall downwards. But here it hits the wall and jumps off the wall at the same velocity. Not the same speed. So what they ask is, in this case, what is the pressure exerted on the wall? So let's say that pressure is P dash. First, I'll build an equation for this pressure. Then I can compare that with P dash. So before finding the pressure, I need to get the force exerted on the wall by this liquid. So for that, I'll just use this equation. V minus U divided by T. This is M over T, that is mass flow rate of the liquid. So for mass flow rate, AV, A times velocity, that is volume flow rate, multiply that by density of the liquid flow, then you get the mass flow rate. V minus U, final velocity is 0. Initially, velocity is V. Since we only need magnitudes, I'll just neglect the negative sign, right? So here force is A V square rho. A V square rho. So then from this equation, I can divide this by A by cross multiplying. Then F over A is V square rho. F over A is actually pressure. That is, so this is one equation. So pressure is V square rho. Let's say this is the first equation. Then I'm going to build the equation here. Here as well, you need to find the force applied on the wall due to the fluid flow. Just apply the same method. Here also, it has the same volume flow rate. So AV rho. But the change of velocity for the fluid, final velocity is to this side. Initial velocity is to other side. A rho V. Then I can change the directions. V plus V. Then this becomes 2V. So this should be A rho v times 2v. This is 2a v square rho. So this is f dash. This is f dash. Then again here, f dash divided by a should be the p dash, pressure here. Then this is equal to 2a v square rho. So then we have two expressions. I'll just write it separately. P equals v square rho and p dash equals 2v square rho. So what we need to find is the pressure exerted at the second case on the wall. So this v square rho is equal to p. So instead of v square rho, I put p here. So this becomes p. Okay, then p dash is equal to 2p. Twice the pressure applied here is applied here as this. So the answer should be 2p. For the 13th question, it should be the second option. Okay, 14th question. A ball weighing 0.15 kilogram moving at 20 meters per second is hit by a cricket player. So from the opposite side, this ball is hit by a bat. Variation of force if applied by the bat on the ball is shown below. So as this ball is being incident on the bat, the variation of force applied by the bat at this time period, I mean it's instant, but let's say shown by this graph, this FT graph. 0.001 second, so this is a small amount, right? The ball is being incident on the bat is like 1,000 of a second. Then this force is given as 13,500 Newton. This time is second. If the ball jumps off to the opposite direction, its speed of cricket ball after a moment of hitting is. So what happens is, at the another moment, this ball gets another velocity to the opposite side. Let's say that velocity is v. So the question what they ask is to find this velocity. Velocity v. Okay. For this one you need change of momentum and you need to find impulse for the change of momentum. So we know impulse is equal to mv minus mu. Impulse and the change of momentum both are same. From a FT graph you can find the impulse. Area of FT graph is equal to the impulse. So I is equal to area. So the area of this one is 13,500 times 0.001 divided by 2. So 13.5 divided by 2, that is 6.75 Newton seconds or kgms minus 1. So this is the impulse due to that collision. And this is 6.75. Okay, that is 6.75. The initial velocity is 0.15 times 20. That is this side. Then the final velocity, but that is to the opposite side. Then 0.15 times v. To the opposite side, let's say that is minus. Then to the other side, there should be 0.15 plus 0.15 times 20, that is equal to 6.75. 0.3, then 3. 0.15 V is equal to 3.75. Then just divide this by 0.15. 3.75 divided by 0.15. 375 divided by 15. 75. Then 3.25. So this is the speed of the ball that bounces off the bat. That is 15 meters per second. So 25 meters per second. So the answer should be the second one for the 14th question. Okay, 15th question. Train carriage with length 11 meters and mass 1000 kg is placed on a smooth rail track. So there's this train carriage which has a mass 1000 kilogram. Then there's a man at another end weighing 100 kg. Then they ask when the man moves from here to here, what's the displacement of the carriage? Since this is on a smooth track, right? Smooth rail track. There's no external force acting on this horizontally. Therefore, when the man moves from here to here, it causes the center of gravity to change. Center of gravity moves from here to here. But without an external force acting on the system, it cannot happen. So what happens is, in order to keep the center of gravity at the same position, the carriage would move backwards. Before this, we will have to find the center of gravity at this instant. So the center of gravity should be somewhere here. Let's say this gap is simple x, and that should be equal to 5.5 meters times 100 plus 1000, then 100. 5.5. This is 1 over 11. So this becomes 0.5 meters. So this gap is 0.5 meters. So this is where the center of gravity is. So if the man moves from here to here, now the center of gravity is here. It is 0.5 meters. So the movement of the center of gravity should be 0.5 plus 0.5, meaning it should be a 1 meter. But it is not allowed because there is no external horizontal force. So in order to prevent that, what happens is the carriage moves backward 1 meter. So that's what's happened. So the answer for that should be the fourth one. That is, the carriage should move backward 1 meter in order to prevent the center of gravity of the system moving forward. Yeah, for the 15th question, the answer should be fourth one.